All right, we are recording so we can watch it back later if that is helpful. Happy Wednesday to you, April 29th. Hooray, we've almost made it through April. You know what they say about April showers? So we got a rainy day out there today. We've been doing a lot of weather talk, exciting stuff. Where are we at in the class? We're getting very close to finishing chapter 7. We will finish chapter 7 today. I sent everybody emails. I created announcements on the Blackboard. Question for the group. When I create announcements on Blackboard, are you seeing them?
Yeah, I also get it in my email.
Okay.
Yep, same here. I'm receiving them to both.
Okay, good job. Awesome. Yeah, so communication is a huge thing. We're all seem to be logging on, so that's really, helping out a lot. But I also write out the communications, so we see them on the Blackboard website. They hit your email. And just so that everybody's on the same page, after today's class, when today's class ends at noon 30, I will launch and I will open up the weather test. The weather test will cover chapters 6 and chapter 7. So you're free to begin that test whenever you want to. Could be today after class, tomorrow, Friday, or Saturday. I have a deadline set for Saturday at 6 p.m. and you should complete the weather test before that time, Saturday afternoon. When you log in, you must finish the Blackboard test within one sitting. So it'll be like a 2.5-hour time limit. You only have one time where you log in and complete the test. So if there's any sort of errors, if there's something wrong and you need me to relaunch the test, then you'll be locked out and you'll have to contact me to try to get it relaunched. So you guys have my number and my email. We'll make it all work. To try to minimize problems that could happen with the test crashing, I ask you to give your computer a fresh reboot. Make sure you got a good fresh reboot on your machine before you begin the test. Don't have any non-essential programs running. Don't have any non-essential web browsers, web tabs open. Really, the only tab you should have open, the only web browser should open is the test. Now, there are supplements and figures. So if you like to have the FAA test supplement figures, then that could be a PDF you have open. If that opens up in a web browser or PDF viewer, whatever works best for you. If you're a person that has the good old-fashioned test supplement book, this is like part of the required course material from the beginning of the semester, then you could also use your figures here. I went through the test and, I updated all the figures, so I don't think you'll have any problems with needing an external figures, but it's still probably good to get in the habit of having those figures handy. So that's the idea of chapter 6 and 7, weather. Are there any thoughts or questions about that process or any of that going forward?
No, sir. Seems pretty straightforward.
All right. Well, it seems like everybody has the right idea that how they're going to log in and be able to take a test for chapter 6 and 7, weather. Okay, I got a phone call from the boss, so administrative item, and it's involving the actual real FAA private pilot written exam. So the idea is that this class, the whole purpose is to prepare you to take the FAA written exam. When you finish this class, if you complete this class, if you pass the class, then you will be given there will be a graduation certificate issued for you. Historically, we, the university, will keep that graduation certificate. We typically keep it in the safe at the Eagle Creek Airport in a folder, and then everybody who took the class this semester, their graduation certificates and their documents involving that exam in this course would be kept in that folder. The university, Vincennes University, will provide you the FAA test. You do not have to go out and spend $160 to take the FAA written exam. The problem is right now with the university, we're not allowed to have any face-to-face one-on-one contact, so we cannot currently give you the real FAA written exam. So in the past, with this class, private pilot, we had given multiple finals, and you had to prove on multiple occasions that you can achieve better than 80% to qualify to actually take the real FAA written exam. So what's going to happen, the boss called me yesterday and explained it to us, is that we will actually not give multiple final tests for this class. So for this class, instead of giving 3 or 4 or multiple tests where you have to prove your ability to get above 80% on multiple takes, we're not going to be doing that because of the online, no face-to-face. It's also an ethical conversation because if somebody is cheating on the test, there's no way for us to know, so we can't truly sign them off to take the real test. Looks like Kai is getting in. Let me mark him in the book. So what will happen is that I only have to provide one final. So I'll only provide one final test. That one final test will occur during finals week. And it'll just be the one final test for this classroom grade. Then fast forward, whenever it happens to be that we're allowed to get together and meet in person and do one-on-one interactions, at that time, then the folks who pass the class and receive graduation certificates, those folks will be administered testing in the computer lab at the Aviation Technology Center, where you have to prove that you can pass at least 3 attempts of 80% or better. And then after you've proved that, then the university will give you the actual administer the real FAA written final. I said the word final. Then the university would administer the real FAA private pilot test. So I know it's kind of tricky. I'm trying my best to explain it to you. It's different this year than ever. So long story short, we are online, we are distance education. You will have a final, but it'll only be one final through Blackboard. That one final through Blackboard will account into your classroom grade. And if you pass the class, then you will have a graduation certificate. The university traditionally holds on to it in the safe at Eagle Creek Airport. That graduation certificate is a document that will let you take the real FAA written exam. The university will give you the real FAA written exam, but we have to hold off because our university policy for main campus is that we can't have any face-to-face interaction at this time. So in the future, when we are allowed to have the face-to-face interaction, that is when the university will let you take the true FAA written test. They will administer it to you. They provide it to you. It's part of the tuition that you've already paid for. And that will be at the Aviation Technology Center. And somebody's messaging me on the Slack, but I don't think it's one of our folks for this class. It's my boss. Is it the same thing? No, okay. So are there thoughts or questions surrounding this process? I may or may not have answers, but I can document them and take them back to our chief flight instructor if we have any question marks.
I got nothing, sir.
All right, well, I appreciate the participation and the response, the feedback. So for us, our plan moving forward then is we're gonna continue with our chapter 7. And I'd like to start by trying to give you all a chance to get some more points in the grade book. So last chapter, which would have been chapter 6, I gave you guys a quiz through the Zoom where you had a chance to build some points in the grade book for the quizzes, and you can respond with a private chat through Zoom. That is perfectly acceptable. If you need to send it to me through email, I prefer my vinu.edu email, but if you send it to my Gmail, that's fine too. just as long as you can submit some answers to me. If you guys get your brains turned on, theoretically it'd be a closed book, closed notes conversation. And I'm going to put up some quiz questions and go with you guys and give you guys a chance to earn some quiz points for the grade book. So I'm going to launch the quiz over here that I have and see if we can start sharing that with you. Okay, seems to be loading up. I'm gonna hit the screen share button. So if you wanted to use the Zoom private chat to me, that works. If you'd rather send it to email, that's fine as well. And you guys should be seeing a PowerPoint that says Chapter 7 quiz. Maybe?
Yes, sir. We got it coming up.
Awesome. We're stepping in the right direction. Okay, Chapter 7 quiz. So be sure to number these and make them nice and clear. Personally, I think it's a great idea to write out the answer if you at least put the number and the letter, those kind of things. So here's question number 1 for our quiz today. And it says between 10 Zulu and 12 Zulu, the visibility at KMEM Memphis is forecasted to be. We have an answer choice A, 6 statute miles. We got B, 3 statute miles. C would be a half statute mile. I'm gonna get my timer going and I'll give you guys 2 minutes for this one because I realize it's a lot of information you have to read through. So I'm gonna give you 2 minutes on the clock. There's 1 minute on the clock. I got another minute for y'all. I've only received a few answers on the Zoom, but maybe some people are sending out emails. All right, I'm coming up on 2 minutes. Is there anybody that's really feels like they need another minute, or are we ready to move on? Any feedback? Okay, so we're gonna go ahead and keep moving forward. If you really need more time, speak up, but I'm gonna keep moving forward. That was question number 1. All right, question number 2. If the terrain elevation is 1,295 feet MSL, what is the height above ground level of the base of the ceiling? So this is a PIREP, a pilot weather report. Involves some math. Could be 505 feet AGL, 1,295 feet AGL, 6,586 feet AGL. I'll give you guys a minute for this one. So there's a minute. I'm just going to give you a few more seconds. I still got some people typing up answers. Just maybe another 20 or 30 seconds. All right, so we're going to go ahead and keep moving. That was a PIREP question for us. Okay, so here is a significant weather prognostic chart. Some people call them SIGWICs. So interpret the weather symbol depicted in Utah on the 12-hour significant weather prognostic chart. So you need to figure out the difference. Which one is the 12-hour chart? You need to figure out where Utah is, and you have to figure out what the symbol could possibly mean. A could mean base of clear air turbulence, 18,000 feet. Could mean B, moderate turbulence, surface to 18,000 feet. Or could mean C, thunderstorm tops at 18,000 feet. I'll start the clock. I'll give you guys a minute for this. All right, so there's a minute. Giving you just a few more seconds if there's any stragglers still trying to send an answer. And we'll keep moving. Okay, so now we're studying some METAR, Aviation Routine Weather Report. It says the remarks section for KMDW has RAB 35 listed. This entry means A, the barometer has risen 0.35 inches Hg. B, blowing mist has reduced the visibility to 1 1/2 statute mile. C, rain began at 1835 Zulu. I'll give you guys a minute for this one. All right, there's a minute. We're going to keep moving. So this looks familiar. We saw this one earlier. This time we're studying the TAF for KOKC. That's Oklahoma City. So in the TAF for Oklahoma City, the clear sky becomes, gosh, we got some long answer choices. A, The sky becomes overcast at 200 feet with a 40% probability of becoming overcast 600 feet during the forecast period between 22 Zulu and 24 Zulu. Could be B, overcast at 2,000 feet during the forecast period between 22 and 24 Zulu. Could be C, overcast at 200 feet with the probability of becoming overcast 400 feet during the forecast period between 22 and 24 Zulu. So we're trying to study the TAF for Oklahoma City, and this clear sky becomes something else, A, B, or C. I'll give you guys a minute and a half for this one on the clock. There's a minute and a half on the clock. If anybody's still trying to get their answer in, A, B, or C, let us know what you're leaning towards. All right, we're going to keep moving. That was the TAF. All right, so here is a weather depiction chart. Question number 6. We're getting really close to the end. I don't have too many more. What is the status of the front that extends from Nebraska through the Upper Peninsula of Michigan? So you got A, B, and C. A, is it cold? B, is it warm? C, is it stationary? It'll be 1 minute on the clock for this one. So there is 1 minute on the clock. We're going to keep moving forward. All right, this is the last of it here. So I got 2 questions on one slide for us. Number 7, absence of the sky condition and visibility on an ATIS broadcast indicates that A, the ceiling is at least 5,000 feet and visibility is 5 miles or more. B, weather conditions are at or below VFR minimums. C, the sky condition is clear and visibility is unrestricted. So number 7, what does absence of sky condition and visibility on an ATIS broadcast indicate? I'm going to give you 1 minute for that. I'm coming up on a minute there. I'm going to go ahead and read number 8 for you. When may hazardous wind shear be expected? A, in areas of low level temperature inversions, frontal zones, and clear air turbulence. B, when stable air crosses a mountain barrier where it tends to flow in layers forming lenticular clouds. C, following frontal passage when stratocumulus clouds form indicating mechanical mixing. So that'll be number 8, when may hazardous wind shear be expected? I'm gonna give you guys 1 minute on the clock, and be sure to get your answers in. All right, so that's a minute and a half. Go ahead and get your answers in. They're all multiple guess, A, B, and C, so you got a 33% chance regardless. Current time is 11:01. So if you're trying to do an email, go ahead and send that thing now. I'll be looking at the timestamp. It doesn't make sense if you submit an email after we've already explained it all. If you're submitting through the chat, be sure to click all your buttons. And I'm gonna go ahead and click off of here. Cool. So give me some feedback. Good, bad, ugly? What do you guys think?
Felt pretty good overall.
Yeah, felt pretty good about it.
So right now I am grabbing all of the chat box. If there's anybody that hadn't submitted through the chat box, speak up now, because I'm copying all that chat box. I'm going to throw it into another document so that way I have it to do some grading with after class today. And we will go over those questions together. That seems like a pretty good next step for us. Fortunately, it takes a minute for me to copy and paste all the answers that came from the Zoom chat box. So I need to create the computer seems to work more slowly when we're streaming. All right, there it was. So I got all of our answers copied onto a document that I can reference later. And together, let's go over some of those questions that we just got some quiz points for. So it looks like, clicking the buttons, you're not seeing it though. Okay, so now everybody sees the TAF.
Got it now.
Okay, so our TAF, it says between, first thing to realize is it's Memphis, K-M-E-M. So there are two TAFs, Memphis and Oklahoma City. And it says between 10 Zulu and 12 Zulu, what's the visibility at Memphis forecasted to be? Well, you start off, here's 18 Zulu to 24 Zulu. There's a probability between 20 Zulu and 22 Zulu. Here's between 22 Zulu. Here's a probability between 20 and 22 Zulu. Here's 2 Zulu. Here's a probability between 2 Zulu and 5 Zulu. We're getting closer. It's becoming something between 6 Zulu and 8 Zulu. Becoming something between 10 Zulu and 12 Zulu. Hey, that's what we're looking for. So becoming between 10 Zulu on the 13th day till 12 Zulu on the 13th day, COM wins, bunch of zeros, 3 statute mile visibility. That's the answer, answer choice B. BR is missed. I was grading somebody's homework assignment the other day and they put drizzle. BR is missed. That is different than drizzle. SKC, sky clear. So right here is the correct answer, 3 statute miles visibility between 10 Zulu and 12 Zulu. All right, let's move to the next. Okay, here is a pilot report, a PIREP. If the terrain elevation is 1295 MSL, what is the height above the ground level of the base of the ceiling? So I'm opening up my calculator on my iPad, and I'm gonna try to type it out here so that way you can work with it. I need to practice getting better with math for everybody because we're gonna have to do more math as we keep moving in the future. So the idea is that we're studying this pilot report. And this pilot report here is saying SK, sky. So there's a broken layer, 1800 bases, that's MSL, a tops 5,500 for those clouds. There's another overcast layer, 7,200 bases, tops 8,900 MSL, and it's clear above. And they're asking, what is the height above the ground level of the base of the ceiling? So you need to know the word ceiling. Overcast is a ceiling, yes. Broken is a ceiling, yes. So the lowest ceiling is actually this broken layer at 1800 MSL. So we have 1,800 MSL. And then in this area, the question tells us the terrain elevation is 1,295 feet MSL. So we'll subtract the 1,295 MSL equal sign to get the answer of 505 AGL. So the answer choice A is the correct answer. So I saw some people, clicking some of the other answer choices. This is the correct answer. The whole idea is that ceiling, broken is a ceiling. Yes, it is. Yes, overcast is a ceiling, but broken is a ceiling.
So we should always expect to see the ceilings, at least on PIREPs, in MSL. I would expect, since we're pilots out there and we kind of refer to our instruments, rather than how it would be on a METAR when it would be an AGL.
100% correct answer. Very good job, Jake.
Okay.
So the
That
idea
makes
is
sense.
that, yep, the ASOS machine or the AWOS machine or the ADIS machine, any of the surface observation stations, they're just looking straight up. So they're just giving you AGL information. A surface observation is just going to give you AGL information. Pilot, they're just going to look at their altimeter. They're going to give you MSL information. Good catch. Oh, I got to hit the clear button on that annotate. We don't want to keep staring at my math all day long. Cool. Okay. So now I will click next and we'll see what the next question had to say on our quiz. Okay. This is a significant weather prognostic chart. They can all look a little different, but this is the one that's currently in the FAA test question bank. And we are trying to interpret the weather symbol depicted in Utah on the 12-hour prognostic chart. So the first thing first, you got to figure out which chart you are supposed to analyze. The first chart, labeled right here in the legend, says it's a 12-hour SIGWIX prog, significant weather. In the bottom legend, it says that this is a 24-hour SIGWIX prog chart. So if you want to answer this question correctly, you need to analyze the 12-hour chart, the 12-hour panel. So up here in the 12-hour chart, 12-hour panel, the next step is to figure out which state is Utah. So unfortunately, being a pilot, geography is kind of important for us. So if you don't know your states, that's kind of one of the things we got to keep working on. We all have our moments. Right here is the state of Utah. I kind of always remember they have like that big Lake Tahoe right here. Lake Tahoe. So this is Utah, and we have a symbol. It's a white symbol. It has a peak with some legs on either side. It says 180 and has a backslash. Maybe it's a forward slash. And what you do is you take a look at the legend, the key in the middle. And the key in the middle is telling us the words moderate turbulence. So that symbol means moderate turbulence. It says 180 with the slash. That means below. So all of a sudden, you're now getting the correct answer of B, moderate turbulence, surface to 18,000 feet. All right, we'll keep moving. Here we are studying some METARs. The remarks section for KMDW, so that's Midway, Chicago, has RAB 35 listed. This entry means we can study it up top, but I don't even think we really need to look at it. Here it is. It's a specie, so they've special reported this METAR. It's not the normal automated observation. At Midway, it was on the 12th day of the month at 1856 Zulu. The wind was 320 true, 5 knots. There was 1 1/2 statute mile visibility. There was rain. Overcast 700 AGL, temperature 17, dew point 16. The altimeter setting 2980. Remarks RAB 35. That means rain, RA, B, began 35 minutes past the hour. This report was issued 56 minutes past the hour. So it's been raining for like, what, 21 minutes? Answer choice should be C. The rain began 1835 Zulu. Down here on the bottom, this JFK, that would be one of the more tricky ones for you to study up on. It says half statute mile visibility, fog, R04. They're describing RVR, runway visual range. So there's a fancy laser machine that points down the runway, and it says looking down runway 4, R04, the runway visual range, the visibility looking down runway 4 is 2,200 feet, RVR. Hey, what do you guys think? JFK, some participation. Do you think this is VFR, IFR, marginal VFR? What's going on at JFK?
That would be IFR.
Very good job, Alec. You might want to pay attention to that one. You might see that question again somewhere. All right, we'll keep moving. Here we are back to that TAF. This one's a little tricky. What makes it tricky is that it's wordy. So again, this comes straight out of the FAA test question bank. In the TAF for OKC, Oklahoma City, the clear sky becomes. There's KKC, a lot of information. You know, here's a broken sky. Here's SKC, so sky clear. So we are studying the TAF for Oklahoma City. We found SKC for sky clear. What's going to happen? What's going to become of this sky clear? Well, if you read the TAF, it says becoming between 22 and 24 Zulu on the 5th day. This is the wind. This is the visibility, rain shower. Here's the answer. It's becoming overcast at 2,000 AGL. And then there's a 40% probability between 0 Zulu and 6 Zulu on the 6th day that these other conditions are going to follow through as well. But wait a minute, we actually didn't need to study all that. All we need to say was sky clear, becoming between 22 and 24 Zulu, 2,000 feet overcast, which is going to be answer choice B. Overcast at 2,000 feet, that'd be AGL, during the forecast period between 22 and 24 Zulu. So if you're a person that's selecting answer choice A or C, those are incorrect answers, and the dead giveaway is OVC 020. That means 2,000. So in your mind, when you're trying to analyze TAF and METAR products, or a lot of weather products in general, you have to add 2 zeros yourself. So 020, add 2 zeros, that puts you at 2,000, not 200. So answer choice A and C are incorrect for that reason. Okay, let's keep moving. What is the status of the front that extends from Nebraska through the Upper Peninsula of Michigan? So here's the front that we're looking at. It's got the sharp icicles sticking out of it. It's cold front. It even actually says the word cold right here on the chart. So answer A, cold front. What you might want to pay attention to is, like, you can see how there's all these different letters, A, B, C, D, E, F, G, and H. So that means in the FAA test question bank, there are separate questions that could ask about every single one of those areas. So if there's any tricky, confusing symbols in any of those areas, you know, I wouldn't mind discussing them with you. Like over here, we have a stationary front. Down here in G area, we got an area where it's cross-hatched, and that's what they're telling you here. If it's a shaded area, that means IFR with ceilings less than 1,000, visibility less than 3. So here in this shaded area, they're predicting IFR conditions. They're not predicting, this is a observation. So they depicted the fact that there's IFR conditions in those shaded areas. If it's a contoured area without shading, I'm just reading the legend here, then that's going to be a marginal VFR area. So here's a contoured line without shading. And so everything inside of that contoured line is reported as marginal VFR. However, if you get a contoured line with shading, that's even lower for IFR. Over here, you have a bunch of open circles. That's going to be some clear VFR conditions. So here is a weather depiction chart, and we're spending some time studying it. And the correct answer for the question is cold front. Remember the difference between, like, the 2 dots, which would be light rain. Over here you have 4 dots, that'd be heavy rain. Here's a little pennant. You see that upside down triangle, little pennant? That means the word shower. So if you have a circle with the pennant, it would be a rain shower. If you have a star with the pennant, it would be a snow shower. Here, you see the little commas? There are 2 little commas. That typically means drizzle. Here you see the equal signs. The equal signs typically mean haze, reduction of visibility. All right, we'll keep moving. And here is our last slide for our quiz. Absence of the sky condition and visibility on an ATIS broadcast. Well, that indicates that the answer choice is A. The ceiling is at least 5,000 feet. Visibility is at least 5 miles or more. That is the correct answer. So when you listen to Holman ATIS, when you're on your way to Terre Haute on a cross country to listen to ATC's recorded ATIS machine, if they don't say anything about the ceiling, they don't say anything about the visibility, then that means that the ceiling is greater than 5,000, visibility is greater than 5. That is different than an AWOS or ASOS machine. Remember, the AWOS and ASOS machines are up to the minute weather. A TIS machine could be up to an hour old information. A TIS would be at a towered airport. Okay, number 8, this is our last question for the quiz today. When may hazardous wind shear be expected? The correct answer is A, in areas of low level temperature inversions, frontal zones, and clear air turbulence. The correct answer, when may hazardous wind shear be expected? Areas of low level temperature inversions, frontal zones, and clear air turbulence. That is the correct answer. Let's have some more information about temperature inversions. On the test, you're going to have some questions about temperature inversions. When I've been reading your homework assignments, I think that there's some misunderstanding about temperature inversion. So temperature inversion, beneath the temperature inversion, the visibility is worse. Above the temperature inversion, the visibility is better. So when I've been reading your short answer homeworks about high pressures and low pressures and your visibilities of good, bad, and poor, there's a lot of confusion on this. So the idea is that, like, a high pressure system has worse visibility. A low pressure system has better visibility. I'm seeing a lot of incorrect answers on the short answers. I'm giving points where possible, but I'm trying not to take off too many points, but I'm letting you know that there's some confusion. A high pressure system is a stable phenomenon. It prevents vertical motion through the atmosphere. So because there's no vertical motion lifting all the contaminants and particulates and dust matter, then the visibility is more restricted. Think about a water, like a stream. Like if you have a water, like a lake, a pond that has no motion, there's no motion, it gets really dark and murky and really difficult to see through because all the contaminants. If you have a river that's flowing down the mountain that has a pretty good flow to it, it might be like a crystal clear stream because that motion is moving and clearing all the contaminants out of the way to make the stream look more clear. So a high pressure system pushes down, creates a cap on the atmosphere, prevents vertical motion. A high pressure system, yes, is a better flying, more stable flying, but the visibility is actually more poor. A low pressure system with its lifting action is going to stir and kick up all that dust particulates, and it'll be less stable, but will actually be better visibility. Here we're seeing the exact same concepts, but now we're talking about it in terms of a temperature inversion. So when you have a temperature inversion, it's almost as if a cap on the atmosphere that prevents vertical motion through that inversion layer. So the area beneath the temperature inversion will have more poor visibility, but will be better, more stable air mass. The air above the inversion layer will have less stable air, but will be better visibility. And yeah, you can have wind shear in the areas of the temperature inversions. Why is it more hazard if it's low level? Because we're getting closer to the land. We're getting closer to land and you're taking off, or where terrain might impact us more if we get some very strong turbulence and winds. We know frontal zones, warm fronts, cold fronts, stationary, occluded fronts. Though, sure, those frontal zones where air masses intermingle, that'd be a great place to find wind shear. And then clear air turbulence, a lot of that has to do with the jet stream. So I want to discuss B and C and explain to you why some of these answers are incorrect after I see some of you guys click some of those answer choices. B, when stable air, that's the dead kicker right there. What's the word? Stable air. So if it's stable air, then you're less likely to see wind shear, hazardous wind shear. You could still find some wind shear, but if you had to choose between A, B, and C, the FAA is trying to clue you that B is the incorrect answer because they're saying the word stable air. They're saying that a stable air crosses the mountain barrier where it tends to flow in layers, forming lenticular clouds. We all agree lenticular clouds are bad. They are turbulent clouds. We need to avoid lenticular clouds. With that said, B is not the best answer choice because it says stable air. And you'll have other questions on the test where you need to pay attention to whether the air is stable or unstable, and I can help you diagnose which is the best answer choice. Answer choice C, following frontal passage when stratocumulus clouds form, indicating mechanical mixing. So strato and cumulus, that's kind of a combination. Generally, the two types of clouds we're discussing are either stratus clouds or cumulus clouds. Yes, a cloud is a cloud is a cloud, so you can label a cloud stratocumulus because it has some stratus qualities, it has some cumulus qualities, but in general, in your mind, at basic level, you're trying to really decide that stratus cloud is more stable. A cumulus cloud is less stable. So in this example, the fact that they're calling it a stratocumulus cloud indicates the fact that there's some stability to the cloud. If it was a straight cumulus cloud, it would be less stable. If it was a straight stratus cloud, it'd be more stable. But the fact stratus gets involved at all tells you that there's some sort of stability to that air mass, indicating what kind of clouds it is creating. So in these answer choices, A is the best answer choice because we have nothing about stable air. In B, it talks about stable air, and C, it talks about the strato cloud, which is more stable cloud. So answer choice A is the best here, according to the FAA. So this was a chance for us to grab a few extra points for our quizzes. Was there any feedback, thoughts, or questions about any of that?
None that I can think of at the moment.
Well, I appreciate the feedback. We are just about finished with chapter 7C. I think there's really only like 1 or 2 more slides. So I'm just going to click through a few more of these slides, 7C, and then we'll take our break. I'm thinking that we left off probably right around here. And you guys are seeing it, but I'm struggling on my end. Let me try again. I am not hitting the right buttons. Why is the thing fighting me? There it is. Okay, cool. I did it. So now if I hit this button, you are seeing the slideshow. We'll click the button to make it full screen. And this is about where we left off. Aviation forecast. So a lot of people will call this GFA, graphical forecast analysis. It used to be called AF for area forecast. It came from FD, which was forecast discussion. Now you might see it called GFA, graphical area forecast, or GFT, graphical forecast tool. And this is what is replacing the old area forecast. And since it's so interactive on the aviationweather.gov site, you can actually click to look at many different layers. So it's a new product, it replaces the old area forecast. And this was some examples we looked at last time. In this case, we see that there's some information for bases and tops. This is a forecast. It's very common that these tops are not accurate, but it's better than nothing. And here is an example where they shows us wind, where we're seeing the wind information. So in this area, we have a pressure system, and yeah, you can see the circulation patterns. We can see the areas of drizzle, the areas of snow, and here they're even spelling it out to you. So the biggest lesson I can tell you is for any aviation weather product that you study, any weather product you study the legend. So you get a new weather product put in front of you, take the time to read the legend, and then you'll have much better luck figuring out what the product is explaining to you. And this is like one of the last slides, I think, volcanic ash forecast and dispersion chart. They say it's retired. This website below provides numerous resources for pilots seeking information about volcanic ash. So it seems to be a NOAA resource, National Oceanic Atmospheric Association, and there's lots of products you could, click through this website to figure out information about volcanic ash. It's a retired product, so nowadays, if we want volcanic ash information, we would probably find that through the in-flight weather advisories. Think about that as like AirMet, SIGMET, convective SIGMET. In this case, I think it'd be a SIGMET. So there'd be a SIGMET for volcanic ash. So that's our commonly used weather products. That was 7C. So basically where we're at now is we're about to launch into 7D, but I'm looking at our clock and I'm thinking that we got ourselves a good pause point. So if there's any questions, I don't mind addressing any questions before the break. All right, so we're going to take 10 minutes and we'll be back. Yeah.
Oh, I have a question. Sorry. So one of the questions I was on I think it was the chapter 7C and D homework.
Okay.
It was asking what the code was for a station that can determine the difference between freezing rain and regular rain, I think. Wasn't it AO2?
I believe so. I'm clicking on it right now, so I might be able to bring it up and we might be able to look at it. So here it is. Let me see if I can bring that up. So yeah, so it looks like we have a blank is the code used to identify the weather observing system that is capable of determining the difference between liquid and frozen precipitation. So you could call it AO2, you could call it ASOS2. There's probably some other names as well. Was there another name you were thinking?
No, I put AO2. I was just asking because it marked it wrong unless I put A02 by accident.
Yeah,
but-
so what'll happen is, the Blackboard system sometimes doesn't auto grade correctly. So it's a
Mhm.
very common occurrence that, when I go through and I click all the grades on my end, I will see AO2 and I would give you the points for it. Since you're bringing it up, I'm going to go ahead and click through on my end and make sure that you get the points for that. And, great. Thanks for bringing it up.
Okay, thanks.
Mhm. All right, guys. Well, we're going to take a 10-minute break and we'll be right back and we'll be on 7D. Thank you. How are y'all holding up?
Doing good.
The birds are chirping outside my window. Must be spring. Well, seems like we're making it back. Everyone's had a chance to use the bathroom, grab a snack, refill their coffee. Long story short, we're about to finish weather. We're about to launch 7D material. After we finish this class today, the test will be open for weather. Where do you find the test? It's on Blackboard, content, chapter 7. So you click in the chapter 7 folder, and that's where you'll find the test. It'll be labeled chapter 6 and 7 test. There's a due date of Saturday. We must get it completed before Saturday, 6 p.m. That's the plan for the weather test. Finish it in one setting. Be sure to give your computer a fresh restart, things of that nature. So I got a PowerPoint here for 7D. I don't think it's going to be too lengthy for us. And if there's any other general questions floating around the room, now might be a good time. Okay, so it seems like everybody's pretty happy and content, so we'll keep moving forward with material. And we should be seeing a PowerPoint that says sources of weather information. Okay.
Yeah, I see it.
Awesome. Thank you for the feedback. You're helping me out. All right, so the first section is talking about pre-flight weather sources. So the best is Flight Service Station, 1-800-WX-BRIEF, I before E. You got to be able to spell brief to get to the correct website or dial the correct phone number. That is the best way, 1-800-WX-BRIEF. Flight Service Station, they handle flight plans, they provide weather briefings. This is one of the big questions on the test. There are 3 types of weather briefings: standard, abbreviated, outlook. Huge question for the test. 3. Standard weather briefing for the day of the test. Remember this: if no preliminary weather checking has been done, then you should get a standard brief. If no preliminary weather checking has been done, you should get a standard brief. That'll be one of your test questions. Outlook brief is if the proposed flight is more than 6 hours in the future. More than 6 hours in the future, you should get an outlook brief. Abbreviated brief would be like if you've already got a standard weather brief a few hours ago, now you just want to get a quick update. Abbreviated briefing. You'll have some questions about calling the flight briefer to call 1-800-WX-FLIGHT brief, 1-800 weather brief, to call 1-800-WX brief, to talk to the flight service station, to talk to the flight service specialist. What kind of things should you say to the actual flight service station specialist? You should tell them that you're a pilot. You should tell them what kind of flight you're looking at taking, whether it's VFR, IFR. You should tell them what's your destination, what's your time en route, what's your altitude. They need to know this kind of information so they can give you the correct weather briefing. You will have multiple questions on the test that involve what kind of information do we give the flight service specialist. They need to know that you're a pilot. They need to know if you're a VFR or IFR flight. They need to know your planned time of departure. They need to know that your planned cruising altitude, your planned destination. They're going to need to know some of this information for them to adequately give you a weather briefing. Standard weather briefing, that's what we said. If you haven't obtained a briefing yet, if you have not obtained a briefing yet, then you should get a standard. It's the most complete briefing, and the briefer assumes that you've not received any other weather information. So they will take more time to thoroughly brief you on the weather conditions out there before you launch. Standard briefing. Abbreviated briefing, that would be if you're updating information from a previous phone call, from a previous briefing. You could ask for specifics such as NOTAMs, TFRs, temporary flight restrictions, or adverse conditions. So it could be the fact that there's some weather out there popping up, and a few hours ago didn't look that mean or nasty, but now you want to get an update. It could be the fact that there was a presidential TFR somewhere in the area and you want to call and get an abbreviated update. Is the TFR still active? Outlook briefing. If the departure time is more than 6 hours in the future, it gives you forecast for initial judgment, still pretty far out time-wise. So even if you did get an Outlook briefing 8 hours ago, probably still a good idea to call and get at least an abbreviated briefing, if not a standard briefing, as you get closer to your actual departure time. There's a website, 1-800-WXbrief.com. You can create a username and password. You can receive all this information digitally if you don't want to listen to another human being speak to you over the phone. The website is great because you can get graphical pictures. So even the picture says 1,000 words, even the most educated individual who's speaking the information to you, sometimes it helps to be able to see a graphical picture. Okay, aviationweather.gov, National Weather Service, Aviation Weather Center. This is a website that we use a lot. We use this website a lot. The big takeaway is that this is not an official weather briefing. So you'll have that on the day of your check ride. They'll ask you what makes a weather briefing official. The answer is that you somehow have a receipt. There is a timestamp. There is a tail number. So when you call the weather briefer, they're going to ask you, oh, what tail number are you flying in? Oh, I'm in 4-1 Victor uniform today. So there's a record that you check the weather. When you just get on aviationweather.gov, the Aviation Weather Center site, when you get on these websites, when you check weather other ways, it is not considered an official weather check. Yes, it's great for you to look at all the information preliminary style, but if anything ever happened and you encountered bad weather and somebody got hurt or something bad happened, there is no official record that you checked that weather. So if you want to CYA, cover your rear end, then you should always get official weather briefings. The best way is to call the phone number, 1-800-WX-BRIEF, talk to a real human being. If you really want to avoid that, you can get on the website, 1-800-WXbrief.com. You can even do it through your ForeFlight iPad app. So private sources. There are lots of places that you can get weather information, whether it's the local news, whether it's a website such as Weather Underground, which is a very good website, the Weather Channel, or SkyVector. SkyVector is a really cool website because it's all about aviation. So they can show you an actual sectional chart, a map, and you can actually see the sectional chart, and they can inlay the weather on top of the sectional chart. Very similar to what ForeFlight does. The difference is that ForeFlight costs money. It's a subscription. It's an official product that we can use as pilots to officially check weather using ForeFlight if you file and click the file and weather brief buttons on your ForeFlight. On SkyVector, we can get a lot of the same information, but there's a certain aspect to it that raises a question mark of, is it an official weather check? I think they're working on the process of getting it certified, but I don't think it currently is. So it's a big issue. Like if you show up today of your stage check or check ride and how you checked all your weather with SkyVector, that may not get you a satisfactory check ride. So we need to use official sources when we're talking about official planning. In-flight weather services. So all those were different ways that we can check weather when we're on the ground before we ever fly in the airplane. Now we're talking about en route. That's a common question that I hear for private pilot check ride. How do you get en route weather? How do you obtain en route weather? The best answer is call flight service. And if you call flight service, the standardized frequency is 122.2, and that's when you're above 5,000 feet. If you're less than 5,000 feet, then you should call flight service on the local frequencies, and those are typically located in blue near the VOR nav aid boxes. Flight service, you can see the sectional chart and chart supplement for the frequencies. Flight service handles flight plans. They provide weather updates. They receive PIREPs. So you want to give a PIREP, you want to ask if there's any PIREPs. I called flight service before and I said, hey, the skies are looking pretty dark up ahead. I wonder if you can give me any update on that weather. So here's some examples of frequencies to get a hold of flight service. And then Indianapolis area, RCO, remote communications outlet, you can get them on 122.55. Here in the Fort Wayne area, you can get a hold of Terre Haute Flight Service Station on 122.45. And you would call that Terre Haute radio. So they have an old-fashioned handle, a name, they call themselves radio. But if you said flight service, they'd pick up on that. You notice some of these charts here, the white charts, those will be the IFR charts, the instrument pilot charts. So you'd be more focused on the VFR charts at this stage of the game. Okay, so goodness, they have retired HIWAS, Hazardous In-Flight Weather Advisory Service. So for years, you would see this H in a circle in the VOR box, and that would indicate that that frequency broadcasts hazardous in-flight weather. And unfortunately, it looks like they retired this service. So unfortunately, you might still see some questions about it on the written exam. What you need to know is that hazardous in-flight weather advisory service would be things like the AirMet, SIGMET, convective SIGMET. And they also have CWA center weather advisories. So any sort of hazardous in-flight weather, historically, you could listen over top of a frequency such as the Shelbyville VOR on 122.0. You would turn up the volume on your navigation radio, and you could listen to a broadcast of hazardous in-flight weather. Typically, they just read you the AirMets, SIGMETs, convective SIGMETs. ATC radar services. So this is all the big topic of how do we get updated? How do we get in-flight weather? Well, if you're getting flight following from air traffic control, you can ask ATC, how does the radar look? So if I'm flying along cross country and the clouds look pretty dark up ahead, I could ask ATC, hey, ATC, I'm seeing some dark clouds up ahead. Can you give me any information on the possible weather ahead? Now, again, air traffic control, their primary responsibility is keeping airplanes separated, the IFR airplanes separated, and they can give you some weather service information, but that is not their primary responsibility. So if time permits, or if their workload permits, that's how the FAA written exam words it. If their workload permits, then they could possibly provide you with some weather information. I've literally had air traffic controllers read me METARs, and that's very nice of them. They're not very busy if they can do that. But areas of precipitation. So especially if you're an instrument pilot and you're flying in the clouds and you can't see ahead, they might call you up, hey, 4-1 Victor uniform, be advised there's an area of moderate precipitation at your 12 o'clock that's spreading 20 miles. And they're telling you there's a 20-mile blob of rain up ahead. So they could see that on their radar. Different air traffic controllers use different radar technologies. So a approach controller, a departure controller, approach, departure, those air traffic controllers are going to have a better radar picture that you can use for weather. Center, if you have an air traffic controller called center, the air traffic controller called center, their radar picture covers such a larger area and points angled so much higher in the sky that their radar picture is not as good for showing weather. Their radar pictures, air traffic controls radar pictures are actually designed for aircraft. It's just happen by chance that they also can see pictures of radar weather as well. As we continue moving forward in technology with ADS-B and our Mode S transponders, we're supposed to see air traffic control get away from using radar technology. So that might also change in the future, their ability to update you on the radar picture. AWOS, ASOS, these kind of stations, they provide real-time weather observations. You call it up-to-the-minute weather. They say ASOS is the most common, and just like Amaya was pointing out, the ASOS 2 or the AO2 There's a bunch of different types of names for it. If you get anything close like that, I'll give you the points on the homework like I did a minute ago. And the idea is that the ASOS2 can determine precipitation type, just like she was saying. It can tell the difference between rain, snow, freezing rain, drizzle, mist. Mist is not truly precipitation. I shouldn't have said that one. AWSS is operated by the FAA, but functions identically from a pilot perspective. There's a lot of different types of surface observation stations. If you open up the AIM, the Airman Information Manual, which is the back of your FAR AIM, there's actually a famous chart that shows all the different types of surface observation stations. On the day of your private pilot check ride, that'd be a good chart to have tabbed out in your book. And you can actually reference it pretty handily and pretty handy and quick when you have to explain to the examiner if the examiner wants to know about the different types. Airborne weather equipment. So now we're trying to talk about what kind of equipment do we have aboard the airplane. We're not talking about call and flight service. We're not talking about call and air traffic control. We're saying what kind of equipment do we have on board our aircraft. Airborne weather radar. It uses a forward-looking radar to search for precipitation ahead, generally operates on 2 bands. X-band can see further, higher resolution. C-band can penetrate further into a storm and provide a more complete picture. Still has the same limitations as ground-based radar. So remember the limitation, dense returns. You could have blind spots behind the weather that you're not seeing, that you're missing out on. Radar, it's going to be line of sight. So if you're trying to paint the picture of weather on the opposite side of the mountain, you won't see it. The mountain is in the way. We do not have this equipment on our aircraft. This would be if you had an aircraft with a fancy radar dish installed on board. Typically, that radar dish would be installed in the nose of the airplane, if it's a multi-engine airplane. If it's an airplane where they have the engine mounted on the nose, like a single engine airplane, then they would have to mount the radar dish somewhere else. Typically, it'd be on one of the wings. You imagine the leading edge of a wing, there might be a very large protruding dome-shaped object that sticks forward. That would be the radar dish. The radar dish should never be operated on the ground. It literally transmits cancerous rays forward. You know, there's a lot of weird conversations about how it can affect people health-wise. So we're trying to get away from using radar technology in this world. Lightning detection equipment. So it can help you to completely avoid storm cells. It does not indicate precipitation, hail. So lightning detection. So it's called a thunderstorm. Where there's thunder, there is lightning. So the whole idea is that if there's a thunderstorm out there and there's lightning strikes, if you had they call this a storm scope. If you had a storm scope installed in your airplane, it would show you the areas of the lightning strikes. I've flown a few airplanes that have storm scopes, and just like the radar technology, you have different knobs in the cockpit to make adjustments, and you can make the adjustment to look at an area that's 50 miles ahead, or only 20 miles ahead, or 100 miles ahead. You have the ability to see different scales. And so that would be, you know, a very important piece of the puzzle for doing lightning detection in the storm scope. Remember, we're supposed to stay 20 miles away from thunderstorms. The reason lightning happens is because there's up and down drafts creating friction. As those molecules rub back and forth with all the wind shear, that's when the static electricity builds up to have lightning. So if there's lightning, there is wind shear, there is hazardous weather that we should avoid in the aircraft. Okay, this is a huge piece of the puzzle for us in our airplane. FISB, F-I-S-B. If you want to get through a stage check with Sean, if you take a stage check with Sean, he's going to ask you about FISB. He's going to ask you, how do we get in-flight weather on our fancy G1000 Cirrus aircraft? And the answer is FISB. There is a dual-bladed antenna on your aircraft that picks up the FISB information, Flight Information Service Broadcast. It is linked with our fancy Mode S transponder. It is part of the ADSB system. Provides a number of broadcast weather and information products. METARs, PIREPs, WINs, TAFs, NOTAMs. It's a free benefit to having ADSB in. Information could be as old as 20 minutes though. FISB. Okay. Well, goodness, that seems to be our slideshow. So we've covered chapter 6 and 7. I'll be launching a test soon. You guys have any general thoughts, questions, comments about weather theory, weather products, anything pertaining to this upcoming test? Seems like you guys are all pretty happy about it. Well, what I'd like to trying to think out loud here. What's going to happen is we're eventually going to move forward and start thinking about the future. So you guys understand there'll be a test. You understand you're going to, take that. And when we get together Monday, we're going to be starting to move forward in time. There's not a whole lot of time remaining in the semester. So after you guys complete the weather test, which will happen, by Saturday, when we get together Monday, yeah, we're going to review some of the tests, but we really need to just kind of start, asking some of those questions that might come out of chapter, 8, 9, and 10. So some of the things that you're going to need to think about moving forward would probably be the idea of the E6B, the whiz wheel. So if when you purchase that whiz wheel at the beginning of the semester, you're going to want to pull out your whiz wheel and you're going to start thinking about the whiz wheel. We're going to have to start going over some of those questions that are going to be involved with the whiz wheel. So I'm thinking that we should maybe start introducing a few other concepts beyond weather and thinking ahead. So what I'd really like to do is try to bring up some sample questions that we're going to be seeing in the future. And so I'm clicking around right now to pull up some of these questions for us. So I got this and it's telling me that I need figure 35. So I'm going to load up 35. Let me throw this over here so we can see what we're looking at. And you guys aren't seeing it yet. I need to click a button. So here's another website that you guys may have seen before. It's called examsforpilots.org. It's not a bad website. I think it works out pretty good. And it says to reference figure 35. So this is just kind of an introduction to some of the weight and balance problems that we might possibly see as we move forward. And I'm fighting Zoom. I got to click this button. There we go. So I'm trying to pull up our figure. It's called figure 35. And I want to walk you through some of the questions that we might possibly see moving forward. So this is a weight and balance question. So we're kind of moving on from weather. And as we think about weight and balance, it's going to involve some math. So there's very simple math that involves weight and balance. There's only two, that's commercial pilot, private pilot. There's only two math problems for weight and balance that we're going to need to get through the FAA written exam. The first weight and balance problem is WAM, W-A-M, weight times arm equals moment. WAM, W-A-M. So as you're taking your notes, this is kind of a new topic. We're beyond weather. The new topic is some weight and balance math. So you're going to have some questions involving math on the final, on the FAA written exam. And WAM, W-A-M, weight times arm equals moment. That is one of the big questions that you're going to have for weight and balance. And I can actually write that out here for you. So let me click the button while the picture loads up, because I can't show the other picture yet until it loads up. But you're going to have weight times arm equals moment. That is one of the big equations that you need to memorize. The other equation that you need to memorize is that mom divided by weight equals CG, which is really the same thing as arm. So just to really make sure that you guys understand this, that's weight times arm equals moment. And here, this would be moment divided by weight equals center of gravity location, which is the same thing as arm. And if I make this sideways for you, you might be able to see it a little bit better. How are you going to remember this? I'm glad you asked. You say the words mom's overweight. Not saying anything about your mother and specifically, but it is a phrase that can help us remember what's going on here. Oh, goodness. Okay.
Hey, my mom heard that. She's mad.
I know. So I got my figure loaded up here. We said figure 35. So let me see if I can get it to load now. It took time. And that's not right at all. Goodness. Airplane weight and balance. We're close. See, it says figure 35, but they've changed the figures around on us. That wasn't very nice of them. Goodness. So let me throw this one in front of you. So here is our testing supplement, and you're going to be using this a lot to get through the, this annotate is really screwing me up. So I got to clear my drawings. Now I got to get back to using the mouse tab. And, oh goodness. Unfortunately, they've changed the figure for us. It used to be called figure 35, and now they have a new name for it. So we will try to grab it real quick for us. They're going to have a 50 pounds of weight located at X, 100 pounds at Z, how much weight must be located at Y? This is a pretty good question to get us started with the weight and balance conversations. But unfortunately, we're not having good luck with it today. This is what I clicked earlier and we didn't get it, did we? Bummer. Well, my goal is not to waste your time. So I guess the idea would be that I'm just going to kind of walk you through what's going on with this. It's all about weight times arm equals moment. Weight times arm equals moment. So the whole idea is that you have 50 pounds of weight located at point X, 100 pounds located at Z. How much of Z? It's a math problem, and we don't really have all the information. It's a bummer. It's a bummer. Let's use this one right here. This is one of the questions that you're going to have on your test. I want to point you to this. This is a conversation about cruise and performance. So while I use my other tab to load up more about our weight and balance here, preparing you guys for that, I would tell you that what you really need to pay attention on this tab, this will be for this is for performance and fuel flow. So the idea here is you're looking at the words that say fuel flow per engine. So PSI would be pounds square inch, whereas GPH would be gallons per hour. So if you have a problem that's asking you about a standard day, International Standard Atmosphere, ISA, then you would find yourself using this gallons per hour, 11.9. If you were anything less than 10,000. Are you seeing the same chart that I'm showing right now?
Are you looking at the
Yeah, we're
page
seeing it.
size
We're seeing
setting?
it.
Okay, so we're just trying to think ahead as we move on from weather. You're going to have a lot of these performance-based questions, and a lot of it's just simple math. And so a lot of it's just trying to figure out how to read a chart and read a table. I found the other one, but I'm going to answer this one because it popped up here. And when you're trying to answer about gallons per hour, you're going to see some information on charts similar to this one. And it could ask you that if you're planning a flight at 6,000 feet and it's a standard day, well, then here's your 6,000 foot, here's your standard day, and you could line up to figure out that you're going to burn 11.5 gallons per hour. Here's a question for the group. How much does fuel weigh?
6 pounds per gallon.
Yep. So all of a sudden it's a math problem. If you was to do, you know, an hour worth of flying and, you know, you flew the airplane for an hour and you were burning 11.5 gallons an hour, then you'd have to do some math to figure out how many pounds of fuel you've lost. So you could have questions like that. So basically, I'm starting to introduce some math problems to you guys that you're going to see in the future. And hopefully you guys are seeing this picture now. Maybe so, yes?
Yes, sir.
Okay, so this is the one that I actually really wanted to focus on to get you going. They're calling it figure 62. Okay, so it's a math problem. And how many slides, what's this called? How many can I really have open at one time? It's craziness. So here's this one. I want to make it smaller. And here's this one that we want to use. So here's our question. And here's our figure that we're going to use. I believe everybody's seeing them all right now. So I'm going to try to use my text tool, and I'm going to try to walk you through some of this math. There's 50 pounds of weight located at point X. Here's point X. There's 100 pounds of weight loaded at Z. Here's Z. How much weight must be located at Y to balance the plank? So we're learning about some weight and balance math. There's only two equations for weight and balance. Weight times arm equals moment. And then mom's over weight. Moment divided by weight equals center of gravity location, or same thing as arm. We'll have a few quick definitions just to bring you up to speed. We have a word called datum, D-A-T-U-M. Datum is just a fancy word for a place to measure from, a reference point. In this case, we're talking about weight and balance, so it's the place we make all the measurements from for weight and balance. Remember when we talked about weather and the atmosphere, we measured it from sea level, the standard datum plane. So in this case, it's a fancy place to measure from. In this example, we're doing a teeter-totter. We're doing a teeter-totter math problem. So we're trying to balance the teeter-totter, and the teeter-totter is located on this fulcrum pivot point. And we have two different boxes at two different locations. In fact, the whole bar balancing act is a piece of the puzzle as well. So we have 50 pounds of weight located at point X. Point X is located 50 inches from the datum. So if I can get this to work for us, we're going to say that 50 pounds of weight is located at point X. So 50 pounds is located at point X. That is how many inches from the datum? Anybody can tell me the answer? Point X is how many inches from the datum? It's right here under my mouse.
50.
50. So I'm going to have 50 pounds times 50 inches. And the math turns out to be, what do we got? 2500. And you call that pound inches. Okay, that is what I'm looking at. So that's point X. So let's make sure to label this nice. This is point X. So that's X. Good information, okay? Now let's see what else I can find. it says 100 pounds is located at point Z. So 100 pounds times how many inches is box Z? Does anybody want to participate? It's right here on my mouse.
100.
100.
100 inches.
100 inches. So at this point, we are getting a lot of decimal places. 10,000 pound inches at Z. Let's see if we can make this wider here for us. Okay. So if you know anything about a teeter-totter, it has to be balanced if you want the teeter-totter to remain balanced. If it's unbalanced, one end's going to drop down. So we want to know how much weight must be located at point Y to balance the planks. Well, it's some backwards math. We know that this is the right side, and we know that X is the left side. So I got 2,000, 2,500. I have 25 pound inches. That's force, 2,500 pound inches pushing on the left side of the teeter-totter. And we've got 10,000 pound inches pushing on the right side. So what are we going to do? We need to figure out how much pound inches force do we need at Y? How much pound inches force do we need at Y to balance this equation? I'm glad you asked. So what we're going to do is we're going to say there's 10,000 pound inches on the right. On the left side, we have 2,500 pound inches. So how much pound inch force do we need to C at Y to balance the plank? Well, the answer is 7,500 pound inches needed to be at point Y, or at box Y, if we want to say the boxes. Okay, there's only so many, there's only two equations for weight and balance, wham, and then mom's overweight. So in this case, we want to know the weight. That's what we want to know. The weight times the arm. In this case, we know the arm for box Y. The arm for box Y is 25 inches equals moment. Well, we know what the moment needs to be. The moment needs to be 7,500 pound inches. So if you guys remember algebra class, you know, if you have like 25W is equal to 75,000, then you like division sign. So like we divide 25 from the left side, we divide 25 from the right side. So if I had 7,500, I just need to write it out for you so you can see it. So if I have 7,500 divide sign by 25, I'm going to get 300. And that's going to be the pounds needed at Y to balance the plank. Is this really complicated? Is this like really confusing? Is it making sense? What kind of feedback do you guys have?
Making sense, kind of.
It's
Makes
making
sense to
a
me.
lot of sense to me, yeah, as well. There was something else I wanted to ask when you're done, and
Yeah.
it's in reference to this particular problem.
Okay.
I believe that I was going through the questions, and one of them said, how many inches do you need to move to the left or to the right
Okay.
to keep it balanced?
The best thing that you guys can do is like when you have those questions, kind of document them, write down the question, write down the figure, and we can bring them up and work on them. And I'm going to try to find that one for you. I'm going to try to help you out with that. Was there any other questions about this particular one?
Negative. I think you hit the nail on the head.
So it's kind of tricky. So I tried to do all my math for you. I'm going to clear the annotations, clear the drawings, and I'm going to see if we can find one that you're referencing where we say it moves around. So we said it's based off of figure 62 we found, and how many inches X, Y, Z pounds. I should type FAA. Yeah, I'm never going to find it that way. That was a nice thought. So let's downsize this one. Let's open this one bigger. And we said it's going to be figure 62. Gosh. And we said move FAA. Yeah, you're gonna have to find the question for me. I'm kind of struggling to pull it up myself.
Yes, sir. It's on. I found it. It's figure 60 weights and balances. It says, "How should here?" I can bring it up on my camera. I don't know if you're gonna be able to see it.
Can you read me the words? Just read me the words real quick. How?
Yes, sir. It says, "How should the 500-pound weight be shifted to balance the plank on the fulcrum?" And
Okay.
then the answers it gives you is 1 inch to the right, 4.5 inches to the right, 1 inch to the left.
Okay, so now we got the question found. That's great. I just had it. How should the 500-pound be? Okay, so here's the question. And we had the picture earlier. We got to downsize this one to make it smaller for you. Okay, so this is the question right here. Can you verify this one for me? Is this the right question?
Yes.
Okay.
Different numbers, but the concept is the same.
Okay, so let's tackle this one since we're working on our weight and balance. And this will probably be our last question for the day as we continue moving forward. So if I annotate text, okay. Now the thought is you're not going to see blue on my blue background. This is not going to work. So how about I change a text to red? We'll be red text people today. All right, so how should the 1,000-pound weight be shifted to balance the plank on the fulcrum? The problem is that we're looking at figure 62, and this says figure 32, and this is not going to be the same information, is it? It's not going to work. So let me try to clear out of my annotations. And let's see if we can find the correct, it says figure 32. Bummer. Hey, this one looks like it might work better for us. Okay, here's a good one. Let's do this one. I like this one. Okay, so here's our picture, and it's not going to work unless I type it out because we want to be able to see it. And this will be our last one for the day. I'm going to text it, and I'm just going to write it over here so we can see it because we'll lose it when it says, how should the 500-pound weight be shifted to balance the plank on the fulcrum? That's the question. Now, if I turn my annotation off, click this button, and if I click here, we can see it better, and we still have our question over here. Great answer. Okay, now I get my annotation back again, and we need to balance the 500-pound weight. So this is the 500-pound weight is in question. So we need to figure out what's going on for the left side of the equation. We need to figure out what's going on for the right side of the equation. Over here on the left side of the equation, we have the 500-pound weight to account for, but this plank exists. So this plank has a certain weight to it. The plank weighs 200 pounds, but its center of gravity is already on the right side. Interesting. We have a 250-pound weight up top, and it's also going to be on the right side. So right now, we can already see, just by looking at it, that the right side of this equation is going to be way heavier than the left side. The right side of this teeter-totter is way heavier. If we want to move this 500-pound weight, I think we're going to have to move it left, but we're not really certain yet. So we need to account, the most difficult part is going to be accounting for what's going on with the right side. So let's start with the right side. So I'm gonna, over here on the right side, that red's all right. I'm gonna try this, let's try this light blue. Let's see if that works for us. So over here on the right side, I'm gonna have, remember, it's very simple. Moment times arm equal, damn it. Ah, gosh. Wham, weight times arm equals moment. That's the equation. Okay, great. So now we have a weight of 250 pounds. That's this box right here. And that's going to be times the arm length of 20 inches. Okay, so I got my calculator open here, and I'm just going to click the buttons. I mean, I should just do the math by head, but you know, if you type it into the calculator, then you can't screw up. It's weight. It's less of a chance you're going to screw it up. So 5,000 pound inches. That is some of the force that's being pushed down because of this box right here under my mouse. On the right side of the equation, we also have the plank. What's going on with that plank? Well, it weighs 200 pounds times the arm length of 15 inches. So again, if you use your calculator, it's less chance of you screwing it up. So I'm at 3,000 pound inches just to do with this plank. So now I have addition math. I have the 5,000 pound inches due to this box. I have plus the 3,000 pound inches due to this whole plank, and all this is on the right side of the fulcrum, on the right side of the teeter-totter. So now I'm up to 8,000 pound inches to account for on the right side of this equation. Is everybody with me so far? Okay,
Shouldn't you add the 15 inches to the 45 for the arm on the right side of the plank? Because the left side arm is 45 inches as it is, and the right side is longer. So shouldn't it be 15 plus 45?
I don't know if you can see my faces I'm trying to make at you. I'm not really certain. I hear the words you're saying. I don't think that's correct. If somebody instructed you that way, then maybe you're onto something that I'm missing. But what I'm seeing is right here underneath my mouse, there's a circle with a cross in it. Now,
Right.
I'm thinking that means center of gravity. So that symbol would mean center of gravity. So yes, this plank has a wingspan, a right wingspan of 45 inches, a left wingspan of 45 inches, but the center of gravity exists right here. And so if you account the sum of all those forces, all the weight, it all pushes down in a centralized location right here where my mouse is. And that center of gravity weight would be 15 inches from the datum. So I'm thinking that whole plank accounts for 3,000 pound inches of force that pushes down, and it pushes down 15 inches to the right of the datum. So that's why I have it over here on the right side.
Okay, makes
So
sense.
on the left side, and this will be our last question, and then we'll let you guys out of here. On the left side, I have a 500 pound box times 15 inches. And so at that point, again, if I use my calculator, I can't screw it up. 500 times 15, I get 7,500 pound inches on the left side. So what have we found? We have found that on the left side, I have 7,500 pound inches. I have found that on the right side, I have 8,000 pound inches. So how much am I really lacking? Oh, it stopped typing. Text. Click. We are lacking 500 pound inches on the left side to achieve balance. There's only two equations, weight times arm equals moment, and then mom's over weight. So in this case, weight, we want to shift that box. We know how much that box is worth. It's worth 500 pounds. Weight times arm. That's what we need to know. We want to know times what arm length would achieve the goal. So there's a few things we could do. We could figure out, we want to know 500, yeah, that's what we want to know. We want to know 500 pound inches. So the idea is that if I have 500 on the left side and 500 on the right side, and I divide by 500, I'm left with A equals 1, which is 1 inch. I need to move the box left 1 inch. What should be the correct answer? I don't know. Maybe that's too confusing. There's more than one way to do these math problems. What kind of feedback do you guys have about this?
I would definitely have to keep doing some of those problems, but at least you pointed me in the right direction. So that to me makes sense how you did it.
So I realize that we're past time. I'm not going to introduce any more questions. This is probably what we expect for our next few class meetings. So you guys are going to take your weather test. As we get together the next few class meetings, we're just going to be working on problems that you find in chapters 8, 9, and 10. So as you guys take more practice written tests and things of that nature, you know, I'll keep pulling up some tricky problems. You guys keep bringing up your tricky problems, and we'll be getting through chapters 8, 9, and 10, the difficult questions. I'm not trying to keep you guys all day. If you have to head out of here, then, you know, I hope you have a great day. If there's any thoughts or questions, I'm happy to stick around and answer those.
Copy that. Thank you, sir.
Hey, thank you.
When is the due date for extra credit?
Well, that's a great question. So I tell you that the finals week is May 11th. So I would say probably, you know, the Friday before finals week. So I'd say May 8th. So May 8th is our last day of normal class, and then we'll have the final during finals week. So I'd say May 8th, if you have any assignments you're trying to get in, be sure to get them in before that. The sooner the better.
Okay, thank you.
Yep.
At one point, sir, did you mention something about you having classroom hours where we can ask you more questions?
Yeah. So right now I'm on a schedule of Fridays, I think 9 to noon, so 9 a.m. to noon. And the way that works is it's through Blackboard. It's very similar to this Zoom where we can see and talk, but I've actually never had any student show up to it. So I don't know if it's going to work, if it works the same as easy, but if I, you know, had knowledge that somebody was trying to, and we were struggling with Blackboard, then we could just launch a Zoom. But yeah, so I am available for, it's called office hours. I'm currently looking at those for Fridays, 9 to 12. And that could be a great time to work through additional questions as well, if you like.
Yes, sir. I was having problems with it on the on Blackboard. I didn't know if it was on Blackboard or Zoom or what have you. But all right, I could try Blackboard again during those hours. If not, I'll send you an email and we could do a Zoom session if that's all right with you.
Yeah, I'm not against it at all. We'll try to use the Blackboard because that's what the university has me set up to do. But if we struggle with it and we can get Zoom to work, then that's fine as well. But yeah, I'm here to help you out.
Don't do it. Really appreciate it.
Hey, thank you.
Have a good one. Bye.
You too. Chance, did you fall asleep?